My name is Dr. Esther Trufant, and in this video, I am going to talk about soap. My great-grandmother used to make soap, and she used animal fats for that, which means that she was using triglycerides. Triglycerides are these esters, and no, I was not named after an organic compound. But esters are the ones that have a carbon-oxygen double bond and a carbon-oxygen single bond. And on the two sides of the carbon-oxygen single bonds, we have two hydrocarbon chains. That means we have an ester. Triglycerides have three of these. So it is a triester. When an animal fat, a triglyceride, reacts with a base, and this can be sodium hydroxide if you are making a solid soap, or potassium hydroxide if you're making a liquid soap, then the product of that reaction, which we call saponification, is going to be glycerin. And this glycerin comes from the left side of our triglyceride, the three-membered hydrocarbon chain with three OH groups. So that's one of our products. On the other part is going to involve the sodium ion from the sodium hydroxide connected to the carboxylate group of the long hydrocarbon chain that is usually a fatty acid. And for today's example, I used the fatty acid from cocoa butter. And this one is a hydrocarbon chain that has 18 carbons, one of which is the carboxylate group carbon. So the carboxylate group, once it is made, it is our soap. And soaps are surfactants, which means that when we mix soap with water, it is going to lower the surface tension of that water. But surfactants are also known for their ability to form micelles. So let's get into this a little bit more. When we look at the structure of the carboxylate salt, then we see two sides. One that has a positive charge and a negative charge. And that one, because of its charged nature, is going to be called hydrophilic, which means it likes water. It likes to interact with any water-containing sources. The other side that has a long hydrocarbon chain is very obviously nonpolar. That one is called hydrophobic because it will hate water, stay away from it, and readily react with materials that are nonpolar in nature or oils. We already know that soap contains this hydrophobic and hydrophilic side, but the way they are oriented in micelles allows us, for one, to wash our hands, because when we put soap in water, the carboxylate salts align themselves in such a way that the hydrophilic side is on the outside and the hydrophobic side is on the inside. So when we wash our hands, the oil or the grease from our hands is going to be in the middle here, in that hydrophobic pocket. Even dust, anything that is not soluble in water or doesn't mix readily with water, will be contained there. And so when we rinse off these micelles, when we rinse off the soap residue, then we remove all of these micelles and our hands are going to be clean. Now, another application is in oil. And in that case, the micelles are simply oriented differently. The outside is going to be the hydrophobic tail of the carboxylate salt, and that one will interact readily with oil. And on the inside, in the middle, we're going to have the hydrophilic side, which will like water. Addition of a small amount of surfactants allows for the mixing of a small percentage of water in various gasoline samples, and it won't come out of it because the surfactants will cause it to remain relatively well dispersed in the oil sample.